Glitch delay is an audio effect rack that consists of one simple delay, one ping-pong delay, and one LFO 2.0, which is a max for live device. Glitch delay can be used to affect audio in a range of ways, from subtle stutter effects to complete aural deconstruction. Hear it for yourself.
When I wake up, the dream comes true. When I wake up, the dream comes true. When I wake
Neat. Now, to help you understand exactly how glitch delay works, we're going to show you how to build this rack from scratch. First, we're going to drag a sample onto an audio track and loop it. You can use any sample you'd like, though we would suggest a percussion-based loop. For this demonstration, we're going to use this basic drum loop. Now, let's drag the simple delay audio effect into our track. Next, we're going to activate the stereo link button. This effectively bypasses the delay time settings for the right channel and applies the left channel settings to both sides. Now let's switch the delay mode from beat sync to time and turn the dry-wet knob all the way up. Now, what we're going to do is play the drum loop, and while that's happening, we're going to drag this delay time slider all over the place. Believe it or not, this here is the foundation of the glitch delay rack. Since manually dragging this slider around can get to be a drag, we're actually going to have an LFO do all the work for us. This LFO to be exact. If you do not already own this LFO device, you can download it for free by using the link in the description of this video. Now, we're going to group everything into an audio effect rack and map simple delays delay time slider to a macro. We're also going to map the beat division parameter to this macro. Next, we're going to map the delay mode button to a separate macro, giving us the option to choose between both modes. Now we're going to map the LFO to the delay time macro by clicking the map button, then clicking the macro. The LFO's control parameter sets the default value of our map macro. This parameter has a range from 0 to 1. We're going to set it to 0.5. The LFO's amount parameter determines how much the LFO is going to modulate our map macro. This also has a range of 0 to 1. And we're also going to set this to 0.5. When this LFO's control and amount parameters are both set to 0.5, we achieve full modulation of our map macro. Now let's choose the random option from the LFO wave menu and increase the LFO's rate to about 5 Hz. Let's listen to what we've got so far. excellent. Notice how the sync delay mode produces more rhythmically relevant results, turning glitch delay into a sort of crude beat shuffling effect. Let's add a feedback macro to spice this rack up even more. Notice that a higher feedback value creates a more metallic kind of sound. Now let's give this rack a dry-wet macro. We're going to do this by creating a dry chain and a wet chain within the effect rack. The reason we're doing it this way is so that we can eventually accommodate a ping-pong delay into this rack. After creating our chains, we're going to access the chain select editor and stretch the zones of both chains all the way out. Next, we'll adjust the fade range like so, and adjust the zone ranges so that we can smoothly transition from a fully dry signal at a value of 0 to a fully affected signal at a value of 127. Now, we can map the chain selector to our dry-wet macro. Great. Remember, you can experiment with this macro to blend the dry and affected signals for subtler or more coherent results. Alright, let's throw a ping-pong delay into the mix to get some really wild stereo field effects. To accomplish this, we need to first group the simple delay into its own audio effect rack within the existing audio effect rack. Now we need to create a mono chain and a stereo chain within this rack, using the same method we demonstrated earlier. Now we need to place a ping-pong delay into our stereo chain. Next, we need to map the ping-pong delay's corresponding parameters to the same macros used to modulate our simple delay. Lastly, we need to fully expand ping-pong delay's bandpass filter and set its dry-wet knob all the way up. Now, let's listen. Holy shit. Now we're just going to add a couple of finishing touches. Let's map the LFO's frequency knob to its own macro, giving us the ability to adjust the LFO's rate. You can set the macro's range however you'd like, but we're going to set it from 5 to 30 Hz. Finally, we're going to map the LFO's curve parameter to its own macro. This parameter skews the LFO's output values. With the curve set equal to 1, the LFO's output is unaffected. When set to a value lower than 1, the LFO will output more lower values. When set to a value higher than 1, the LFO will output more higher values. Again, you can adjust the range of this macro to your liking. We're going to use a range of 0.3 to 3. Well, there you have it, the glitch delay audio effect rack. Now that we've built the rack, we're going to demonstrate what happens when we change the delay's delay transition mode. You can do this by right-clicking on the delay's title bar, and selecting one of the transition modes at the bottom of the option list. Repitch mode will make the delay behave like a tape delay, where changes in delay time affect the pitch of the output. Jump mode causes audible clicks when the delay time changes. This can really mangle and distort the output. We're actually going to put a limiter at the end of our effects chain because things are about to get really fucking loud. We apologize in advance. pretty. Now we're going to demonstrate the glitch delays effects on different kinds of audio. First, let's try using it on a melodic element, like this piano loop. Compared to a percussive loop, glitch delays effects are less obvious. However, stereo mode can create a lot of interesting and busy textures. Lastly, let's use glitch delay on a full-blown song.
When I wake up, the dream comes true. When I wake up, the dream comes true.
Using audio with both rhythmic and harmonic elements can result in some really wild stuff.
When I wake up, the dream comes true. When I wake up, the dream
Consisting of only 2 delays and an LFO, glitch delay is truly a testament to what can be achieved by a simple yet streamlined design. It also demonstrates the power and versatility of LFOs in a sound design workflow. We highly encourage you to incorporate an LFO or 2 into your own audio effect racks in the future. We hope this video inspires you to experiment even further. And if you're willing to share, we'd love to hear your work. Until next time, goodbye.